All right, so we're supposed to locate the relative maximum point and relative minimum point of g, graph the function and its derivative, indicate the relationship between any relative extrema of g and the corresponding points on the derivative graph. All right, so probably a little bit of calculator work is going to be necessary here. So g prime of x is going to be equal to what? Well, if we take 3 times that, that's going to be a 0.12x squared minus 2 times that, 16, 17, so 0, oh no, not 0, 1.76, sorry. 17, 6, 1 point there, and that's an x, and then plus 4.81, okay? I can't factor that one. So I'm going to say, okay, well, let's let x equal a minus that. So it's going to be plus 1.76 plus or minus the square root of negative 1.76 squared minus 4 times 0.12 times 4.81 all over and 2 times 0.12. Okay. So if we plug that into our calculator, we're going to get all right, so if we do the plus, we'll get x equals, and we get 11.0339. That's good enough. And if we do the minus, we get 3.6327, and then that rounds out. It's good enough. So those are our values for the extreme points where this is going to be the true case. Now we plug those back into g of x. We'll have g of 11.0339 and g of 3.6327. So if we do that, then we just plug in those in. I'm not going to write all that out. So that's going to give us 3.63 I did, I guess, first, so that's going to be 19.8879. Now I plug in the other one, and 11 is going to give us 11.7795. Okay, so if we know one's the max and one's a min, well, our height here is going to tell us that one. So this has to be a relative min, and this one has to be the relative max. Okay. And again, if we're thinking about how this works, we have a positive, so we're going to have some kind of a function that's going to be like this. And I don't know, if this is at 3.6, we maybe that's going to be our axis there. And it's always going to be a positive, so it's going to be something like that. And so now we have to think about this one. That's going to be a positive. It's opening up. Well, it should be crossing. Now I'm going to be running into an issue where I'm going to be too low, but it's going to be, I don't know how it's going to look. It's going to look something like that, and then it's going to come back up and something like that. But those are going to line up, okay? And that's going to be a key. Now, do we need to make it a prettier graph? We can plug it into our calculator and see, but that's going to be the point here, the relative max. 3.63, let's just do it to 2 so I can get it to fit in here, 19.89, and so this one's going to be 11.03 comma 11.78. Okay, but you know, with all the decimal places, at least 4 of them, we have those. If we only are going to put 2, that's what we'd have here. So now we've kind of got our graph. We've got, you know, the original, we've got the derivative. The derivative crosses here and here at the c values. Okay, so that's what we wanted. And what else does it say? Relative strain. Well, you know, this point corresponds to, you know, our relative extreme max, and this point relative extreme min. So that's how they relate. And again, you know, all we did was we took the derivative, we used our formula here, got our two values for x in this case because it was a quadratic. Then we've plugged those values back into our original function. We got our 2 points here, and so then that's where we got. Now, if we want to do anything else, you know, we could plug it into our calculator to see what it really looked like as far as how good of our graph we came up with. But I would say for sketching it out, this would be good enough. All right, so here we have a river flow rate. And it says, suppose the flow rate in cubic feet per second of a river in the first 11 hours after the beginning of a severe thunderstorm can be modeled as such, where h is the number of hours after the storm began. What are the flow rates for h equals 0 and h equals 11? So that just says for f of 0 equals what, and f of 11 equals what? Well, f of 0, that's 0, that's 0, that's 0, so we get 123.02 cubic feet per second, okay? Now f of 11, we just have to plug 11 here, here, and here, and if we plug those in, it's going to be a bigger value, I'm pretty sure. So it says 331.305 cubic feet per second, okay? So that's A. Now B, calculate the location and value of any relative extremes for the flow rate. Well, we're going to have to take the derivative first. So f prime of h is equal to, now 0.865 times 3, so that's negative 2.595 h squared, and then plus 12.1 h, and then minus 8.95, and then the rest goes off, and this is CFS per hour, okay? And so now what we have to do is we have to solve this. So we're going to plug it into our nice little equation again. So we'll have x equals negative 12.1 plus or minus the square root of 12.1 squared minus 4 times negative 2.595, and then times the negative 8.95, and then that's all over a 2 times negative 2.595. And so I'll plug that in my calculator here while we're doing it. And when we do that, I'm going to pause and then I'll go type all that in. All right, so I typed it in and it's really H, so I put it back at H. So we got 0.3875 for one and 8.8995 for the other. And then what we need to do is we need to find F of 0.3875 and we find F of 8.8995. So we're plugging it back into then our original function. So when we do that, when I did that, I was already on the thing. So that was equal to 121.3109, and that was equal to 388.0473. Okay, so that gave me those values. Now calculate the location and values of any relative extremes for the flow rates on the interval between h equals 0 and 11. All right, so what we need to do now is we're thinking, hey, we've got a different sign up here. So it's actually going to be, instead of like we saw before, like this, it's going to come down. It's going to be something like that. Okay, so we're going opposite sides. We've basically switched them around, because when you have a positive there, you would have this, but when you have a negative, you're to this. Now, since this is a 0.3, that must be the minimum. And so our curve, if we think about it, it cannot, the 0.3 is just to the right of that. So that has to be our x-axis. So this is going to be our 0.39 comma 121.31. And so that's a relative min. Okay. And so then our other point here is going to be our relative max, and that's the 90 comma 388.04. And again, if that's just in 2 decimals, and that's our relative max. Okay, so the location and values of any relative extremes, well, that's the 2 relative extremes that we have. And this is going to be, again, the key thing you need to do is to solve this function here, okay? Now, anything else we need here? It doesn't say to draw any graphs, but I drew the graphs just to kind of show you where those extreme points are and why they are what they are. Okay. And that's all I have. So hopefully that helps.